Sometimes when studying for the ACT, we get so caught up in trying to solve the pre-algebra, algebra, geometry, trig, and probability questions that we forget to study some simple definitions. The ACT almost always has a question or two that ask about types of numbers or ask you to categorize a specific number or a solution. And they're easy points if you understand the definitions, or it's an easy lost point if you don't. So in this video, I want to review the different types of numbers. And if we follow the kind of flow chart that I created, you'll see that complex numbers include all numbers, all real and imaginary numbers. They can be broken down into those two categories. I'll go into the definitions of each of these categories in a minute, but I just want to kind of show you the flow here. So the real numbers can be broken down into rational numbers and irrational numbers. The rational numbers can further be broken down into integers, whole numbers, and natural numbers, which are all considered rational. Integers include the whole numbers and the natural numbers, and the whole numbers include the natural numbers. So you cannot go in the reverse direction. You cannot say that the natural numbers include the whole numbers or the whole numbers include the integers, etc. But you can go from one direction to the other. So that basically means that complex numbers include everything. The real numbers include all the rational and irrational numbers and anything below it. And the rational numbers include everything below it on the flowchart as well. We're actually going to start defining these numbers now. So we're going to start with the natural numbers. So the natural numbers are the counting numbers that we learn as children. So these include 1, 2, 3, etc., all the way into infinity. The whole numbers include all natural numbers plus 0, so 0 and all natural numbers. Some definitions include 0 in the natural numbers, most however do not, so we're going to categorize them this way. The integers include all the whole numbers and all of the negatives of the natural numbers. So we'll just put on here, dot, 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 -3, -2, -1, 0, 1, 2, 3, dot, dot, dot. Okay, so that's the integers. Rational numbers include all numbers, integers, whole, natural, and any numbers that can be written as a fraction in the form of, let's just say, x over y, where x and y are integers and y is not 0. X and y are integers and y does not equal 0. The rational numbers include the integers, whole, and natural numbers because you can write any of those numbers as a fraction. So the number 2, for example, you can write that as a fraction of two integers written as 2 over 1 or 4 over 2. So those all fit into that rational category as well. Irrational numbers are numbers that cannot be written as a simple fraction. So the irrational numbers have essentially two things that distinguish them. They are decimals that go on forever, and they are decimals that do not ever repeat. So we have numbers like pi, e, the square root of 2. Those are just 3 examples of them. But again, they have to have the two things in common where they, as decimals, they go on forever, and again, they do not repeat in any way. The real numbers are basically all rational and irrational numbers. Imaginary numbers essentially are I. So I is the symbol we use for imaginary numbers, and I is equal to the square root of -1. So we know from basic convention to math that we cannot take the square root of a negative number. So there's actually a class of numbers that can end up actually being really useful, called imaginary numbers, and that's represented by I, which is equal to the square root of -1. Complex numbers are all real and imaginary numbers. And these can be represented by this formula, a plus bi, where a is the real component and bi is the imaginary component. So b can be, a number such as 1, 2, or 3, or 1.5. It just represents the number of times that I shows up. So anything can be categorized as a complex number as shown in the grid above, because if you have a number such as 5, for example, well, you would say, well, is that complex? Well, yeah, you can write 5 as 5 plus 0i. So it takes the form of a plus bi, where a is equal to 5, b is equal to 0, and then you get 5 plus 0i. Likewise, you can have a number like 4i, and it can have no real component, so it would just be 0 plus 4i. So everything falls in the complex category.